Hey there folks, Mr. Dickin here. In this video we're going to learn how to verify whether two separate functions are inverses of one another or not. Some good news on this lesson. You'll notice there's no homework. What's going on? So this is just kind of a little add-on to your inverse knowledge. So if you're ever presented with two functions, you'll be able to determine, hey, are these inverses or not, without having to go through the rigmarole of graphing them and figuring out if their x's and y's are flip-flops of one another. I should make note, a lot of time as well with these, you'll probably be able to look at them and tell, and I'll give you some pointers on that when we get there. So first, how do we verify this? Well, we use function composition. So if two functions are inverses of one another, you have to be able to plug one function into the other and vice versa and get a resulting plain old x, which is called the identity function, right? That's that dotted line that we were drawing on the previous lesson's graphs, y equals x. So we're going to have to do composition, f of g, and then everything will cancel out except for the x. And then we have to go through and do g of f, and we should see everything canceling out except for the x. So let's take a look at some examples here. We want to determine algebraically if the functions f of x and g of x are inverses of one another. You'll notice on f of x, I have my variable. It's being multiplied by 3, and we're adding 2. So if I completely flipped and reversed and inverted all of that, right, multiply by 3 and then add 2, going backwards, that would be take away 2 and divide by 3. And as I'm looking over here, x, I take away 2 and I divide by 3. So just at first glance, yeah, these already kind of look like they're going to be inverses. But let's prove algebraically if they are. So first, I need to do f of g of x. So that means I need to take this g function and I need to plug it in for x on the f function. So that's going to be 3 times x minus 2 all over 3, plus 2. So if I were to multiply this 3 into the parentheses, I've got a 3 in the numerator, 3 in the denominator. Those would knock each other out. So I'm just left with x minus 2 plus 2. Well, minus 2 plus 2 cancel each other out, and I'm just left with x. So far, so good. That's checking out. Now let's do the same thing over here. I'm going to plug the f function into the g function. So I need to figure out g of f of x. So that's going to be 3x plus 2 minus 2 all over 3. All right, so this chunk right here is just replacing for the x. All right, so plus 2 minus 2, those cancel each other out. So now I'm just left with 3x over 3. 3's knock each other out, and I'm just left with x. So hey, example 1, those are in fact inverses of one another. Yay. Second example, we have the third root, or the cubed root, of x minus 4, and then x to the third power plus 4. Now this, to me, kind of passes the eye test, right? Because I have x, I take away 4, and I take the third root. If I think backwards, I'd have to add 4 and cube it. So it looks like it probably would work out, but let's double check just to be safe, shall we? First one, if I plug g into the f function, that'd be the third root of x cubed plus 4 minus 4. Plus 4 minus 4, those cancel. I have the third root or cubed root of x cubed, and that's just going to be x. So it works that way. Let's try g of f of x. So I'm going to plug the f function in for x over here. I'd have the third root of x minus 4 to the third power plus 4. A cubed root and a cubed will knock each other out, so I have x minus 4, and then I'm adding 4. Hey, that works. So those are, in fact, inverses of one another. One more and then we'll call it a day. See if I just kind of give it the old eye test like I was doing before. Here I'm multiplying by 3, then taking away 4. So multiply by 3, then subtract 4. If I reverse and invert that, I should add 4, divide by 3. It looks like I've got the 4 and 3 backwards, but let's double check with some algebra, and if that is the case and it is backwards, that will manifest here. So first, f of g of x. I'll have 3 times x plus 3 all over 4 minus 4. If I simplify that, ooh, this is going to get gross. The 3 and the 4, those aren't going to cancel, so it looks like this 3 is just going to have to go ahead and distribute into the numerator. So that's going to give me 3x plus 9 all over 4 minus 4. Yeah, that's not going to work out to be a plain old x. So for this last example here, these are not inverses. And to be honest, I kind of saw that coming because right here I feel like those 3's and the 3 and the 4, those were backwards. So that's it, folks. If you're ever presented with two functions and you're wondering to yourself, hey man, are these things inverses? Now you know how to figure that out. You know the drill. If you have any questions, let me know. And as always, good luck, have fun, be safe, and roll tide.